Have you ever wondered how dirty water becomes clean? At Dr. Shankar Chelam's lab at the Zachary Department of Civil Engineering at Texas A&M University, that's just one of the many problems that they're working to find answers to. Civil engineers use their knowledge of science to construct buildings, improve roads, and lessen the impact of human activity on the environment. Today we'll be looking at how to clean up water like this. The most common process used involves coagulation, flocculation, and filtering.
What does this mean? Well, let's consider any sample of water from a random dirty creek or dirty pond. If you take a cup of that water and give it time to settle out, sure, some larger chunks will fall to the bottom, but the water will still remain fairly cloudy. This is because smaller particles do not have enough mass to fall to the bottom of the container on their own. And most of these impurities are negatively charged, which means that they will stay away from each other, and they're not going to want to clump together. A process called coagulation involves adding a positively charged chemical to destabilize these negative charges, allowing them to stick together and form into larger clumps. These clumps are called flocks. After flock formation, we can again let the container of water sit, and now that the smaller impurities have joined together into larger clumps, these flocks, they will settle out to the bottom of the container. Now the water is ready to be purified through a process of filtration. Filters come in all different types, but a simple filter that can be made that mimics fairly well the filtration process used at commercial water purification plants use a layer of sand on top of a layer of gravel on top of a layer of charcoal or activated carbon. The activated carbon is very porous. It has a lot of surface area, and it's able to absorb many of the impurities that make it past the sand or the gravel.
So here's the water that we're going to be purifying today. It's 500 milliliters of pond water taken from a pond near A&M. I'm going to add a stir bar to allow us to mix this water sample during coagulation. The chemical that we're going to be using to coagulate today is aluminum sulfate, which is a very common coagulant.
The process of coagulation takes several minutes, so this is a sped up video of that process. The stir bar at the bottom of the beaker is spinning, allowing all of the ions that are produced to come into contact with impurities. After several minutes of coagulation and flock formation, the stir bar is turned off, and you can see there is a great deal of sediment that forms at the bottom.
See, after it's had a chance to settle out, the water is a lot cleaner. A lot of the impurities have been removed. However, it is still a little bit cloudy. So we are now going to need to filter it. As I explained earlier, filtering is a process that goes through different layers of materials to help clean the water. So we're going to construct this filter with a soda top from a 2-liter soda bottle. I'm taking a coffee filter, rubber banding that around the bottom here, and into that bottle I am now going to add activated carbon. It's just essentially charcoal. Next, a layer of gravel. And finally, a layer of sand. Now that the filter is set up, we are ready to filter. I'm going to slowly pour the water on top of the filter. And as it flows through, the water is left much cleaner. The sand, the gravel, the activated carbon, are removing the impurities that were left in the water here. You'll notice I don't need to pour all the water in. The water at the bottom, what's called sludge, is where all of the dirt and germs, many of those have gone to, so that can stay at the bottom. And the water that flows through is much cleaner. We just saw the process of coagulation, flocculation, and filtration, which is how water is traditionally cleaned up. At the Chelum lab, they're also working on a process called electrocoagulation, where instead of using chemical coagulants, the coagulating ions are produced through an electrochemical reaction.
In the process of electrocoagulation, direct current is passed through two electrodes that are placed in the sample of the water to be cleaned. At the anode, the aluminum electrode is oxidized to produce aluminum ions, which are going to destabilize the impurities in the water and cause flock formation, much as the way that the aluminum ions from the alum did the same thing in chemical coagulation. The cathode will be reduced, producing hydrogen and hydroxide ions, which can further help clean the water. This process is very interesting to Dr. Chelum and his colleagues who are interested in cleaning hydraulic fracturing fluids from oil production sites. The advantages of this method over chemical coagulation are it's more portable, it's cheap, and also with the production of some bleach products that are formed, it can help clean the water even more thoroughly.
The electrodes that we will be using today are an aluminum anode and a steel cathode. The aluminum anode fits inside of the steel cathode like this. And you'll notice that the cathode has holes in it to allow the dirty water access to both electrodes.
Here's a sped up video of the electrocoagulation process. One interesting thing to note is, unlike chemical coagulation, the electrocoagulation is actually producing some bleach, making the water look much cleaner during this process. And after a period of time to allow the flock to settle, as before with the chemical coagulation, the water that's been cleaned through the electrocoagulation can be run through a filter, resulting in the end with pure water, just as before. I'd like to thank you for watching this video about water purification today. For more information about what's going on in Dr. Chelum's lab, please visit his website. I'd also like to thank those who were involved in helping to make this video during the course of my summer with the E3 program at Texas A&M University.